Hello everyone. Let us go through the velocity components. See in a turbo machine. See here I am having a rotor. Okay, that rotor having two radius. This is the R1 and this is the R2. So radius R1, it is a point I will call it as a G, and radius R2 I will call it as a S. Okay. At the point one, the fluid is entering. Fluid means that may be either air or that may be either water, anything. Okay, the fluid is entering at the point G. Okay, that is called as inlet. Okay, that is called as inlet. Point G is the inlet and point S is the outlet. Okay, the fluid is entering at the point G, which is the inlet, at radius R1. At radius R1, then it is having the velocity in different directions. Those velocities in different directions are called as the velocity components. See, the fluid is entering from A to G, that is called as V1, which is the absolute velocity. This absolute velocity having the velocity components in a different directions, x, y, z. Here my x, y, z are the axial flow component and radial flow component and the tangential flow component. See, V1 is entering from A to G, then it has the axial component along the axis. This is the axis. Along the axis, that will be the VA1. And along the radial direction, this is the radius. Okay, this is the radial direction. That is the velocity component is Vm1. That is Vm1 along the radius. See, if I draw a tangent, then this V1 will have the one more component, that is the tangential velocity component. So it is like this. It exactly looks like tangent if you draw a line to that. Okay, it's in tangential direction. This velocity component, it's a tangential velocity component. So V1 is the absolute velocity component. It has three V1 is the absolute velocity. It has three different components: VA1, VU1 and VM1. VA1 is the axial component, VM1 is the radial flow component, velocity component, and VU1 is the tangential velocity component. This is at the radius R1. And similarly at the radius R2, okay, we'll have three different components of velocity, absolute velocity. So V2 is the absolute velocity that is coming out of this point 2, also point S. Okay, here 1 and S, they are represent 1 and 2, they are represented like that. So 2, at 2 it is the radius R2, and from 2 the absolute velocity is coming out of that, it is outlet. Okay, it is outlet tip. From here our fluid is coming out of that, that is the V2 absolute velocity. And along the axial direction it has a component, that is VA2. And this is the radial direction, this is the radius, look at this. And here this is the radius, look at this. And this is the radius here, so that will be the VM2. And if you draw a tangent like this along our at the surface of this rotor, okay, then we will have a tangential flow component. This is tangential flow component, that is VU2. Okay, I think you are understood here. So this will be the VU2. If you are not understood, you can call me and ask the doubts for this. Okay, and here next we will have one more figure next. So here the same thing, B to H is the V1, that is fluid is entering at the inlet tip of the fluid, that is known as V1 absolute velocity. And it has a along the axis of this rotor, this is the axis OO, I will write as OO. This along the axis of this rotor, that is va1. Okay, and this is, so look at this, this is towards radial direction, this is upside in the radial in brothel radius. Okay, that is towards radial direction, that is the vm1, that is at the entry. And this is, if you draw a line here, it looks like a tangent, that line is a tangent at the surface. If I had drawn this a to b, looks like that tangent drawn to the rotor surface. So this is a tangential flow component, this is vu1. Okay, that is vu1. Similarly here also at the outlet tip also you can have these velocity components. Okay, you will have these velocity components. So these are the velocity and velocity components of this absolute velocity. I have written all the terminologies here. V1 is the absolute velocity at inlet, VA1 inlet axial velocity component, Vm1 inlet radial velocity component, Vu1 inlet tangential velocity component, V2 absolute velocity at outlet, VA2 outlet axial velocity component, VM2 outlet axial velocity component, VU2 outlet tangential velocity component. Here this is the wrong I have written. This will be the radial velocity component, that is. Here I should write this one is the wrong. This is outlet radial velocity component, that is. That is outlet radial velocity component. These are the things. Okay. Axial velocity components creates axial thrust. It is absorbed in the journal bearing, which is not useful for us. And radial velocity component creates the radial thrust, which is absorbed in the journal bearing. That is also not useful for us. The only component, velocity component, is tangential velocity component, which is useful for us. So that one we can use afterwards, and we will have the uh, Euler's turbine equation. Okay. Now we will see there are various components. Okay, there are various components of this absolute velocity v1. Those are vu1 and va1. Okay, vm1, and these are the velocity components. So, but if you want a solution for a problem, then you should form a velocity triangle of these velocity components and this v1 also including. Then only you can solve a problem. It is not. It is very difficult to solve a problem with this without arrangement, without having velocity triangles. Now we will arrange these velocities in the velocity triangle and we will understand it. So here I will draw a blade. I have drawn this blade. Okay, this velocity blade I have drawn here, and this velocity v1 that is entering here, that is, this is two-dimensional figure I am drawing. You will not, you should not get confused with the three-dimensional figure. Okay, you should not get confused with the three-dimensional figure. Okay, I will draw this. Okay, this is the v1, that is fluid is entering with some velocity. This v1, that is v1 velocity that is entering, and here also that v1 will have entry here to this inlet. Okay, now this is the tangential flow. This is vu1. Vu1 is the tangential flow component, and this one is the radial flow component, vm1. and this is the VA1. For this case here, so this is the axis of this rotor. Okay, I have drawn here, this is a 2D figure, not a 3D figure. This is the 3D figure. Okay, so that for me only this radius is visible here in 2 dimension. Okay, for me only this radius is visible here in 2 dimensional, so that I will form a velocity triangle by using this radial velocity component Vm1. This is upside like this, which is okay, I have drawn here, and this is a tangential component. This one I will draw here. This is the tangential step like this. I have drawn a blade here. Okay, this is a blade I have drawn. Okay, now this will be the VU1. I will point out like this. From this to this is the VU1. And for this problem here, axis is same. For this problem here, axis is same. Look at this. This is the axis. Axis is not changing. The radius, we are considered two radiuses, that is here up to at the inlet blade of tip. This is VM1, and here for the radius R1, that is this is, and here R2. So two radial positions we are considered. So your blade varies, okay, from R1 having at the inlet tip and R2 at the outlet tip. Okay, the radius and the flow is radial flow like this. Flow is radial flow. As the flow is radial flow in the radial direction, okay, we are considered only VM1 here. So we are not considering this VA2. The reason is that flow is radial direction. Okay, flow is in the radial direction like this. So fluid is flowing, entering here, tip 1 in the radial direction, and fluid is exiting at the radial direction at the point 2. This is 1 and 2, I will write. Then this is VM1, this will be the VU1. Okay, I think you are understood this much. And here one more thing, if it is axial flow machine, then this is radial flow machine. For radial flow machine, I have drawn like this. And if it is axial flow machine, here, okay, if it is axial flow machine, the fluid is flowing in the axial direction like this. For this case, the fluid is flowing in the radial direction. In this direction. See, these are the two cases. So here fluid is flowing in the radial direction, and here fluid is flowing in the axial direction along the axis. Okay, here fluid is flowing in the axial direction like this. These are the two cases. ಅಲ್ಲಿ ರೇಡಿಯಲ್ ಫ್ಲೋ ಮಷಿನ್ದಾಗ ರೇಡಿಯಲ್ ಫ್ಲೋ ಇರ್ತತಿ, ಇದು ಆಕ್ಸಿಯಲ್ ಫ್ಲೋ ಮಷಿನ್ದಾಗ ಆಕ್ಸಿಯಲ್ ಫ್ಲೋ ಇರ್ತತಿ. Okay, for this case, see V1 that is entering, I will have a same blade once again like this. This is 2D figure I am drawing. ಇದರೊಳಗೆಲ್ಲ ನಾನು ಇದನ್ನು ತೋರಿಸಿಲ್ಲ, ಬ್ಲೇಡ್ ತೋರಿಸಿಲ್ಲ, ಕನ್ಫ್ಯೂಸ್ ಆಗಬೇಡ್ರಿ. ಇದರ ನಾನು ಬ್ಲೇಡ್ ತೋರಿಸಿಲ್ಲ. Okay, V1 this is entering, and this is tangential direction. It's a tangential flow. ಇದಕ್ಕೆ ಹಿಂಗೆ ಡ್ರಾ ಮಾಡೋದಂಗಿರುತ್ತೆ ಟ್ಯಾಂಜೆಂಟ್ ಆ ಕಡೆಯಿಂದ ನೋಡಿದಾಗ. ಇದು ಇಸ್ V1, ಅಂಡ್ ಇದೇನಿರ್ತದಲ್ಲ ಇದು ಅಲ್ಲಿ ರೇಡಿಯಲ್ ಫ್ಲೋಗ VM1 ಅಂತ ಬರದೆ, ಇದು ಆಕ್ಸಿಯಲ್ ಫ್ಲೋ ಮಷೀನ್ಗೆ VA1 ಕನ್ಸಿಡರ್ ಮಾಡೋಣ. ಯಾಕಂದ್ರೆ ಫ್ಲೋ ಏನೈತಲ್ಲ ಫ್ಲೂಯಿಡ್ ಆಕ್ಸಿಯಲ್ ಫ್ಲೋ ಇರ್ತೈತಿ, ಇಲ್ಲ ಇಲ್ಲಿ ಎಂಟ್ರಿ ಆಗತ್ತ, ಇಲ್ಲಿ ಎಕ್ಸಿಟ್ ಆಗತ್ತ. ಸೊ ಇದ್ರದ್ದು ಫ್ಲೋ ಅಲಾಂಗ್ ದ ಆಕ್ಸಿಸ್ ವೇರಿ ಆಗತ್ತೆ ಇಲ್ಲಿ, ಅದಕ್ಕೆ VA1 ಅಂತ ತಗೊಂಡಿ ನಾ ಇಲ್ಲಿ. ಓಕೆ, ಅಲ್ಲಿ ರೇಡಿಯಲ್ ಫ್ಲೋ ಮಷೀನ್ನಾಗ VM1 ತಗೋಬೇಕದನ್ನ ಇಲ್ಲಿ ಮ್ಯಾಗ, ಇದಕ್ಕೆ ಏನೈತಲ್ಲ ಇದಕ್ಕೆ ಇಲ್ಲಿ VM1 ಇದಕ್ಕೆ. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ಫ್ಲೋ ರೇಡಿಯಲಿ ಫ್ಲೋ ಆಗ್ತಿರೋದು ಮತ್ತು ರೇಡಿಯಲಿ ವೇರಿಯೇಷನ್ ಆಗುತ್ತೆ. ಓಕೆ, ಅಲಾಂಗ್ ದ ರೇಡಿಯಸ್ ಇಟ್ ವಿಲ್ ವೇರಿ. ಇಲ್ಲಿ ಆಕ್ಸಿಯಲ್ ಫ್ಲೋ ಇರಂಗಿಲ್ಲ, ಇದು ಆಕ್ಸಿಸ್ ಇದರದ್ದು ಇಲ್ಲಿ. ಓಕೆ, ಇಲ್ಲಿ ಇರಂಗಿಲ್ಲ, ತಿಳ್ಕೊರಿ ಇದನ್ನು, ಇದು ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್ ಐತಿ. ರೇಡಿಯಲ್ ಫ್ಲೋ ಮಷೀನ್ಗೆ VM1, ಅದ ಇಲ್ಲಿ ಆಕ್ಸಿಯಲ್ ಫ್ಲೋ ಮಷೀನ್ ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ಇದು ಅಲಾಂಗ್ ದ ಆಕ್ಸಿಸ್, ಇದು ಹಿಂಗ್ ಮೂವ್ಮೆಂಟ್ ಆಗ್ತಿದೆ ಅಲಾಂಗ್ ದ ರೇಡಿಯಸ್, ಇದು ಅಲಾಂಗ್ ದ ಆಕ್ಸಿಸ್ ಮೂವ್ಮೆಂಟ್ ಆಗುತ್ತೆ ಇಲ್ಲಿ, ಅದಕ್ಕೆ ಇಲ್ಲಿ VA1 ಅಂತ ಬರಿಬೇಕು. ಅವಾಗ ತಿಳಿತ್ರಿ, ಇಷ್ಟು ತಿಳಿತ್ರಿ ಸಾಕು. ನೆಕ್ಸ್ಟ್ ಪಾಯಿಂಟ್, yes, here I told you already, this is the 2D sketch of the blade. This is the 2D sketch of the blade, whatever I have drawn, and this will be the 3-dimensional sketch. And now I will have a velocity that is V1 that is entering the blade here somewhere. V1 that is velocity of a fluid that is entering here, V1, and it has a velocity component. One is V1, and for this case it will be VR1 or VRD1, radial velocity component. Now look at the blade tip here. See, V1, VM1 and V1. Now these three velocities, okay, only two velocity components I considered of this absolute velocity V1. So the angle here, this is alpha 1, I call it as, this is known as absolute velocity angle. Alpha 1 is known as absolute velocity angle. And now along when this V1, it is a entry, after touching this tip, it will follow the blade design. Okay, the fluid will follow the blade design. Whatever the blade shape is there, according to that fluid will start to flow over that. So ಇದ್ರದ್ದು ಈ ತರ ಕರ್ವ್ ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ಹಿಂಗ ತಿರುಗ್ತದ ನೀರು ಅದ್ರ ಮ್ಯಾಗ ಬಂದ, ಯಾವ ಡೈರೆಕ್ಷನ್ನಾಗ ನೀರು ಇದು ಯಾವ ಡೈರೆಕ್ಷನ್ ಬ್ಲೇಡ್ ಇರ್ತತಿ ಅದ ಡೈರೆಕ್ಷನ್ನಾಗ ಫ್ಲೂಯಿಡ್ನು ಫ್ಲೋ ಆಗಿ ಚಲೋ ಆಕತಿ. ಓಕೆ, ಅದಕ್ಕೆ ನಾವು ಅದ್ರ ಮ್ಯಾಗ ಏನ್ ಹರಿತೈತಲ್ಲ ನೀರು ಅಥವಾ ಫ್ಲೂಯಿಡ್, ಅದಕ್ಕೆ ನಾವ್ ಏನಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ ರಿಲೇಟಿವ್ ವೆಲಾಸಿಟಿ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಈ ಟಿಪ್ ಡೈರೆಕ್ಷನ್ ಏನೈತಲ್ಲ ಅದ ಟಿಪ್ ಡೈರೆಕ್ಷನ್ ಒಂದು ವೆಲಾಸಿಟಿ ಹುಟ್ಟುತ್ತತೆ. ಓಕೆ, ಈ ವೆಲಾಸಿಟಿ ಇಲ್ಲಿಗೆ ಹೋಗಿ ಬಡಿತೈತಿ, ಬಡದ ಮ್ಯಾಗ ಇದ್ರ ಮ್ಯಾಗ ಹೋಗುವಂತ ಹರಿಯುವಂತ ವೆಲಾಸಿಟಿ ಏನಪ್ಪಾ ಅಂದ್ರ ಅದು VR1. that is relative to this blade tip, that is related to the blade tip, that is written as VR1. That is okay, that is the VR1. This is VR1, which is known as relative velocity. Its angle is beta 1. Its angle is beta 1. Its angle is beta 1. So there is a blade tip angle. Beta 1 is known as blade tip angle or else relative velocity angle also. Beta 1 is the blade tip angle, that is a relative velocity angle. So here A, B, C and this one D I will write here. So A to D, A to C is the VU1. A to C is VU1. Now the distance, that is AD, what is that? AD is my question. What is that? That is we should know. So AD is the tangential velocity. We will call it as U1, that is at the inlet side. U1. That is difference between V1 and VR1. That is. So it will be in between V1 and VR1. Okay, VR1, it is the flow that is along the blade tip. That is a flow over the blade tip. Also, you can call it as over the blade tip. That is VR1, relative velocity over the blade tip. And this U1 is the one which is used, which is the velocity of this blade, which is used by this blade to move. Okay, which is used by this blade to move. Okay, that is the tangential velocity. That is the tangential velocity. So U1 can be written as whatever the difference between the V1 and VR1 is there, that is the U1. The difference between V1 and VR1 is the U1. So I have used some portion of velocity of this V1, okay, to move this blade. Some portion of this V1 I have used to move this blade, okay, at the inlet side. Andre some energy of this V1 I have used to move this blade. The remaining one is the VR1 at the inlet side here. That is along the blade tip. Okay, that is U1 tangential velocity of this blade, we will call it as, or tangential velocity of this rotor also we can call. That is the similarly here at the outlet side. So if this is the VR2 along the blade tip, VR2 ಹಿಂಗ ಹೊರಗಡೆ V1 ಬರ್ತಿತ್ತಂದ್ರ V2 ಬರ್ತಿತ್ತಪ್ಪ ಅಂದ್ರ, okay, here. So if this is the VR2 along the blade tip, ಇಲ್ಲಿಂದ ಬ್ಲೇಡ್ ಟಿಪ್ ಬರ್ತಲ್ಲ ಅದ್ರ ಪ್ರಕಾರನ ಮಾಡೀನಿ, ಡ್ರಾಯಿಂಗ್ ಮಾಡೀನಿ. And this is the VR2 along the blade tip, and V2 throwing away like this. ಹೊರಗಡೆ V2 is throwing away like this. This is along the blade tip at the outlet. Then this is V2. So V2 is the absolute velocity. As early absolute velocity here V1 having the components VU1 and VM1. Similarly, at the outlet side also it will have the components, two components, okay, that is VM1 and VM2 and VU2. See, VM1 here it's a radial velocity component at the inlet side. Similarly, VM2 is the radial velocity component at the outlet side. Is a radial velocity a flow. ಇದೇ ರೀತಿ ತೋರಿಸ್ಬೇಕು ಇದನ್ನು ಕಂಪಲ್ಸರಿ. ಓಕೆ, ಇದೇ ರೀತಿನ ತೋರಿಸ್ಬೇಕು. ಇದಕ್ಕೆ ಅಟ್ ದ ಟಾಂಜೆಂಟ್ ಡ್ರಾ ಮಾಡ್ದಂಗೆ ಇರ್ತದೆ. ಇಲ್ಲಿ ಹೊರಗಡೆ ಸೈಡ್ ಹಿಂಗೆ ಟ್ಯಾಂಜೆಂಟ್ ಡ್ರಾ ಮಾಡ್ಬೇಕು. ಅದಕ್ಕೆ VU2 ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಮಟ್ಟ ಏನು ಬರ್ತಿದೆ ಅದು VU2, ಅಲ್ಲಿಂದ ಅಲ್ಲಿ ಮಟ್ಟ ಅದು VU2. ಮತ್ತೆ ಇದು ಎರಡರ ನಡುವರ ಕಷ್ಟ ಇಲ್ಲಿ ಡಿಫ್ರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದಿಸ್ V2 ಅಂಡ್ VU2. VR2 ಈಸ್ ಏನಪ್ಪಾ ಅದು U2. ಇಲ್ಲಿ ಇಲ್ಲಿ ಬರೋದು ಇವೆರಡರ ನಡುವರ್ಕ U2. ಇಟ್ ಇಸ್ ಟ್ಯಾಂಜೆನ್ಷಿಯಲ್ blade velocity, this U2 at the outlet side, at the outlet side, at the outlet side, it is. Okay, tangential blade at the outlet side, this is. Okay, ಇದು U2 ಅನ್ನೋದು ಬ್ಲೇಡ್ ವೆಲಾಸಿಟಿ. ಓಕೆ, ಇದರದ ಬ್ಲೇಡ್ ಮೂಮೆಂಟ್ ಇಲ್ಲಿ ಒತ್ತಿ ಹಿಂಗ್ ಹೊರಗಡೆ ಇದು ಇಲ್ಲಿ ಲಾಸ್ಟ್ ಟಿಪ್ಗೆ ಏನು ವೆಲಾಸಿಟಿ ಇರುತ್ತಲ್ಲ, ಫ್ಲೂಯಿಡ್ ವೆಲಾಸಿಟಿ ಇಲ್ಲಿ ಒತ್ತದ ಇಲ್ಲಿ ಬಂದು ಇದು ಒತ್ಕೊಂತ ಬಂದಿರ್ತದೆ. ಇದ್ರ ಮ್ಯಾಗ ಹರ್ಕೊಂತ ಬರೋತ್ನಾಗ ಒತ್ಕೊಂತ ಬಂದಿರ್ತದ. ಅದನ್ನ ಬ್ಲೇಡ್ ಮೂಮೆಂಟ್ ಆಗತ್ರಿ ಅವಾಗ. ಓಕೆ, ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್, ಬ್ಲೇಡ್ ಮೂಮೆಂಟ್ ಆಗತ್ರಿ. ಸೊ ಅವಾಗ ಇದು ತಿರುಗ್ತತ್ರಿ ಮುಂದಕ್ಕೆ. ಈ ತರ ಇದೊಂದು ವೆಲಾಸಿಟಿ ನಾನು ನಿಮಗೆ ತೋರಿಸಿದೆ. ಓಕೆ, this is VM1. This is the velocity triangle we formed to solve the problems. ನಿಮಗೆ ಇದು ಈ ವೆಲಾಸಿಟಿ ಕಾಂಪೋನೆಂಟ್ಸ್ ಏನಿದ್ವಲ್ಲ ಇದನ್ನ ನಾನು ನಿಮಗೆ ವೆಲಾಸಿಟಿ ಟ್ರಯಾಂಗಲ್ಸ್ ಒಳಗೆ ಹಾಕಿ ತೋರಿಸಿದ್ದೀನಿ ನಾನು ಇಲ್ಲಿ. ಇದು V2, ಇದು VM2, ಇದು VR2, U2, VU2, ಇದು VR2 ಇದು. ಓಕೆ, ಇದು VR2, ಮತ್ತೆ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬೇಡ್ರಿ, ಇದು V2. ಓಕೆ, and next I will clear everything here. And next I will have one more blade shape. If it is blade shape is like this, the blade shape is like this. If the blade shape is like this and this is the V1 that is entering, that is the V1. This is a 2D sketch, keep in your mind. This is 3D and this is the 2D. So this is the V1 that is entering. Okay, it has the two components. The one is, anyhow it has three components, but for me I am considering only two components for the solution purpose to form the velocity triangle. Okay, this is the VM1 and one more velocity component, that is VU1. These two are, it is along the tangential direction. This is okay, along the tangential direction. ನೋಡ್ರಿ, ಈಗ ರಿಲೇಟಿವ್ ವೆಲಾಸಿಟಿ ಡ್ರಾ ಮಾಡೋಣ ರಿಲೇಟಿವ್ ಟು ದಿಸ್ ಬ್ಲೇಡ್. ಓಕೆ, ಇದು 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 ಎಂಟ್ರಿ ಆಗೋದು ನೀವು ಕೊಟ್ಟಿದ್ದ ಡೈರೆಕ್ಷನ್ ಇದು ಇದು you whatever the direction you are provided, that is coming out of this pipe, and when it will touch this blade, it will follow the blade shape. The fluid will follow the blade shape, so that whatever the velocity of the fluid is there over the blade shape, so that one I am drawing here. This is the VR1, that is the VR1, and the angles here, V1 is alpha 1 and VR1, the angle made with the VR1, that is beta 1. That is beta 1. Okay, the difference between these two, that is U1. ಅವೆರಡರ ನಡಬರ್ಕನ ಬರ್ಬೇಕ್ರಿ ಅದು. ಓಕೆ, ಯಾಕಂದ್ರೆ ಇದ್ರದ್ದು ಪೋರ್ಷನ್ ಆಫ್ ಎನರ್ಜಿ ಯೂಸ್ ಆಗಿರ್ತದ್ರಿ ಇದನ್ನ ಮೂವ್ಮೆಂಟ್ ಆಗಕ್ಕೆ ಮುಂದಕ್ಕೆ. ಇದು ಈ ತರ ಮೂವ್ಮೆಂಟ್ ಆಗತ್ರಿ ಬ್ಲೇಡ್ ಯು. Okay, the blade movement is in this direction. Though this is the U1. Okay, the blade will move in the right side here. ಇದು ಯಾವ ಡೈರೆಕ್ಷನ್ ಆಗಿ ಹೋಗಿ ಹಿಟ್ ಆಗುತ್ತಲ್ಲ ಅದ ಡೈರೆಕ್ಷನ್ ಬ್ಲೇಡ್ ಮೂವ್ಮೆಂಟ್ ಆಗುತ್ತೆ. V1 ಯಾವ ಡೈರೆಕ್ಷನ್ ಇರುತ್ತೆ ಅದ ಡೈರೆಕ್ಷನ್ ಇದು ಮೂವ್ಮೆಂಟ್ ಆಗುತ್ತೆ. ಯೂಶುವಲಿ V1 the direction we should show afterwards. So here I think you are understood now till this. Next, uh, see, now VR1 that is entering either ಮೇಲೆ ಹರಿತೈತ್ರಿ, it will flow over this and it will exit here. VR1 this is VR2 that is, it is exiting here, and V1 will be in this direction, and blade is moving towards the right direction in the direction of V1. So I assume it's a general velocity triangle. I assume this V2 will also be in the towards the right side. ಯಾಕಂದ್ರೆ ಇದು ಈ ಕಡೆ ಮುಂದಕ್ಕೆ ಹೋಗಿದ್ದು ಅಂತ ನಾವು ಹಿಂಗ್ ಇದು ಎಂಟ್ರಿ ಆಗತ್ತೆ, ಇದು ಮುಂದಕ್ಕೆ ಈ ತರ ಮೂಮೆಂಟ್ ಆಗ್ತಿರೋದ್ರಿಂದ, ರೈಟ್ ಸೈಡ್ ಮೂಮೆಂಟ್ ಆಗ್ತಿರೋದ್ರಿಂದ V2 ರೈಟ್ ಸೈಡ್ಗೆ ಬರುತ್ತಂತ ನಾವು ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಳ್ಳೋಣ ಈ ತರ. Okay, so VR2 is the along the blade tip. This is along the blade tip, that is VR2. So V2 it is coming out of the blade tip, that is V2 is the coming out of a blade tip. So it will be direction of the whatever the blade moment is there, that is the V2 direction almost. Okay, and this is the blade tip angle, whatever it is there, that one. Now I will show the velocity components for the V2. So this is the velocity components I have drawn here. So I will draw a horizontal line here. ಇಲ್ಲಿ ಇದು V2 ಇರ್ತತ್ರಿ, ಇದಂತ V2 ನಿಮ್ಗಂತ ಕನ್ಫರ್ಮ್ ಐತ್ರಿ. Okay, now this V2 has two components, that is one is the tangential flow component, the one more is the radial flow component. It has two components. Okay, one is the radial flow component, one more is the tangential flow component. See, radial flow component, it will be in a tangential direction. Radial flow component, it will be in the radial direction, and the tangential component will be in the tangential direction. Okay, V2 has two components. One more component, that is the axial component, is neglected here. So I will draw this tangential component up to this. This is the tangential component, whatever I have drawn. This is the tangential component. So this is V2, that is, and the angle made by this absolute velocity at the outlet side is the V2 alpha 2. And here this one, this is the radial flow component, as V1 having Vm1, so this is the Vm2. Okay, now I will join this line here, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ join ಮಾಡೋಣ್ರಿ. So this distance, the difference between V2 and VR2 is the U2. ಅದು ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಮಟ ಇದಿಷ್ಟು VR2. Okay, U2, sorry, that is this is the tangential velocity. Okay, U2 is known as tangential velocity at outlet. Okay, this angle is the beta 2. This angle is the beta 2, that is, if you can show here also is beta 2 dash or beta 2, you can refer afterwards when you are solving the problem. Okay, so beta 2 I will have written inside, one is the beta 2 dash, one side ಅಷ್ಟ ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡತ್ತೀನಿ, ಈ ಸೈಡ್ ಇದು ಆಲ್ಫಾ 1, ಈ ಕಡೆ ಬೀಟಾ 1, ಇದು ಆಲ್ಫಾ 2, ಈಚೆ ಕಡೆ ಹೊರಗಿಂದ ಬೀಟಾ 2, ಒಳಗಿಂದ ಬೀಟಾ 2 dash, ಈಚೆ ಕಡೆ ಆಲ್ಫಾ 2 dash. So this is regarding the velocity triangle. And if it is an axial flow velocity, if it is an axial flow machine, okay, if it is an axial flow machine, then the flow is along the axial direction. Okay, this is the radial flow machine. Once again, this one, this is the axial flow machine. The flow is along the axial direction, like this, ಈ ತರ ಹರಿತೈತ್ರಿ along the OO, that is axial flow direction. Then this Vm2 will be written as Va2, and this Vm1 will be represented as VA1. So this is regarding the drawing the velocity triangle and velocity components. Okay, so you just go through this video and let me know if you have doubts and call me and ask the doubts. Thank you, Nandal. Okay.